Hi everyone, my name is Raunak Parmar. So in today's session, we are going to talk about how I and my colleague leveraged a basic reader role in Azure and become a global admin, and not just global admin, but even were able to access Intunes, DevOps, on-prem services, more than 25 subscriptions, and yeah, and a lot more stuff. So about me, my name is Raunak Parmar. I work as a senior cloud security engineer at White Knight Labs. I'm OSW certified. My area of interest is in AppSec and CloudSec. For cloud, mainly in Azure and AWS. I'm also an author of a tool named Vajra, Your Weapon to Cloud. I've been a speaker of multiple conferences, and I used to be a DJ and a music producer as well. Unfortunately, my friend didn't made up this year because he had some medical issues. So he also works with me as a senior cloud security engineer. He's into Active Directory, Azure Network. He's a creator of some open source tools like process injection, Scalidus, etc. He's also a trainer at Black Hat, besides Milano, etc. And obviously some more conferences as well. Okay. This is what you see is the complete attack part of what we did from complete scratch as a reader role within our client's Azure account. So in the left side where you see a big circle where is the written attacker, so from where we got some multiple attack scenarios from where we were able to become reader to owner, then we were able to be a reader to Intune admin, reader to on-prem by accessing on-prem services, and a lot more stuff. So I will be taking you to the journey of this attack part, how we leverage and compromise all those services within 3 weeks of time. So let's start. Since I have a lot of slides, a lot of topics, I will be not going too much technical. I will just going to give a quite overview about how and what happened. So a company named XYZ gave us some tester users, and we had some basic reader permissions over the Intra ID and the Azure root management. So basically, it allows you to have reader roles over all the subscriptions that the Azure has. So me and Chirag, we both divided our jobs of enumerations. So we did our own personal enumerations, and the main motive was to break something like as much as we can break, and that's what we did. We break a lot of stuff. So initial enumerations. So we started with the basic enumerations of understanding the company needs, what are the different resources being used, and we observed that the company was using lots and lots of VMs and disk. But those were not that useful as a reader user, but there were some juicy services known as automation accounts, function apps, and logic apps. Why? Because these services allows you, as a reader permissions, allows you to read the source code of those services. And that's all we wanted to have. So generally, there is no tool that allows you to perform a scan and like gives you all the internal data of the services. But I had my own personal tool, which I have made a private version of it. So it allows me to perform a scan and take all the source code of all the function apps, logic apps, automation accounts, runbook, jobs. And by having those thousands of codes, I can just quickly search a keyword and get that source code, get that particular section. So this is a screenshot of my tool, and this is just a dummy code. So here you can see I performed a scan and found a logic app where it has a workflow, and in which I found the service principal credentials. And since we had a reader permissions, we can quickly just check what permissions that service principal had, which is basically an app registration. So we found that that app has application.readwrite.all, which means we have kind of got a shadow admin app. So because we had a permissions to write applications, we can add new client secret within that app. It's quite similar like having an IAM key. So in IAM key, we add more secrets, right? But in Azure, we can have multiple secrets, and there is no limitations. So we used that app and added some more client secret and got access, and like we can like leverage any, we can like compromise any other apps. So the main goal was to find out an app which had some higher privileges like global admin or something else. But we didn't found any different app which had the same privileges. So, but we did found one app which had application admin permissions. So by using our first app, which we found in the logic app, we used that first app to add a client secret in another applications and compromise that app. So now we have application admin permissions. So with app admin, now we can have certain high-level privileges and have complete control over the app registrations and the enterprise apps. So both are quite different, but works a bit similarly as an attacking point of view. So till now, we have enumerated the app registrations and found that there was an app which has app admin permissions, but we didn't did for the enterprise apps. So for similarly, I used my own tool, Vajra, and I found out that there was one app within the 6,000 enterprise apps. I found one app which had this permissions, which says group read write.all. That means if I now compromise this app, and from this app, if I found another group which had some more privileges, I can just directly add my tester user within that group, and I can gain those privileges. So we started hunting back. I added my own user within that group by using that enterprise app. So this was a great win, because right now we have permissions to add users in any groups. But there was an issue. Once we found out that there is a group which has global admin permissions, we tried to add our users within that group. But because that group had admin permissions, now that group is called privileged group. Now because that group is a privileged group, I cannot add any user from just having a group read write. I would need an admin permissions myself to add any user. So we failed at this point. So that's not an issue. We continued our hunting back, and this time we perform enumeration within the Azure services. See, intra-ID resources or Azure AD roles and subscription roles works completely different. So we had to do enumeration 2 times. So within the subscriptions, when we found that there's a service principal who had a contributor role over a resource group, and that resource group had certain function apps, and those function apps were using some code where it was trying to communicate with the on-prem server by PS remoting. So I will hold this attack part here and will come back on this part in the next section. So we continued enumerating the roles within the root management. As I said, root management is the highest hierarchy within all the subscriptions comes under. So within the root management group, we found the one group which had owner privileges. That means if somehow I am able to add myself within that group, I can be an owner of all the subscriptions within my client's Azure account. And luckily, that group didn't had any intra-ID roles, because if that group had any intra-ID admin roles, I wouldn't have been able to add myself. So luckily, it didn't had, and I just add my tester user within that group. And guess what? Previously, when we were having reader, now we have owner permissions over all the 25 plus subscriptions. That means I have control over more than 3,000 services within my client's account. So from the attack point of view, there's a red circle. So this is the part till now we have reached. So now we'll talk about the second attack part, which is reader to AED connect code execution, which means we pivoted from cloud to on-prem. So as I said, we found a function app which had some code doing invoke command, basically a PS remoting stuff. So because we had a contributor role, okay, this is the output. Here you can see there's some invoke command going on, and the credentials is being taken from the environment variables. So because we had a contributor role, we can easily grab those credentials. We tried to run the same command from our own system, but it didn't work well. So we tried to check the networks of that function app, and we found that the function app is using a hybrid connections. So in hybrid connection, what happens is your function app will be able to talk to the on-prem server, and no one else will be able to do that. So that means that we have to leverage function app. We have to get into the function app within its network, and then we need to try to connect the on-prem server. So for that, we could have used the function code, and again we could have triggered those functions. But there's something else which is called as publish profile. So publish profile is a file which has certain credentials which Visual Studio uses to deploy some applications, and it contains basic or credentials as well. So here you can see in the function app, we have get publish profile. So when you just download it, you get a file something like this, and you have a username and the password. So once we use it with the URL which says function name scm azurewebsites.net and /basic auth, you will get the prompt to put those credentials. And once you do that, you have access to SCM portal. So SCM portal is like a management console of the app services within the Azure, and it uses a kudu service. So it allows you to communicate to the function apps terminal. So it's kind of a cloud shell, in other words. So from here, we were able to execute commands and everything. And we found out that the function app also had permissions on the key vault. So we quickly grabbed the token within the from the function app, and we got the secrets from the key vaults, and those secrets were the credentials of the application proxy. So since application proxy was configured in a way that you need to be a member of the specific group, and since we had application admin permissions, we added ourselves in that specific group and got access to the application proxy. And by using these credentials, which we got from Key Vault, we were able to log in. But since there is nothing we could have done that, I didn't add it in the slides. OK, so let me talk about the Microsoft Intra Connect Sync. I'll just give a quite overview. So Microsoft Intra Connect Sync is something which allows you to synchronize your on-prem and the Azure AD cloud. So let's say if you have certain users in your on-prem systems, it will make sure that those users are also available in your Intra ID, and the passwords and other objects get synchronized every 2 minutes. So here you can see there's a SQL database which is automatically being created, and in this there are credentials of 2 different users. One, we have MSOL, and second, we have sync. So MSOL has the permission of replicate directory changes all permissions on the on-prem. So it makes sure that if there is any changes happen in the on-prem, it will inform the Azure Intra ID, and the sync account and the sync user which is being created, it will make sure that those changes are done within the Intra ID. So basically, sync user is responsible to update the users within the cloud. So that means that this account has certain high-level privileges, or maybe this account can update the password of the global admin as well. So that's what the goal was for us. We could have used a tool named AD internals, but because that tool is now been marked as a malicious code, so we were not able to use that code within this. So we used another script which is written by Adam Chester, and it allowed us to grab the credential of MSOL user. But to grab the password of sync user was a bit difficult. So Chirag and I spent some time writing this custom code, and I'm not going to go deep within how we bypassed or how we leveraged this, because this would take another whole session. So somehow we wrote some custom script and got the clear text password of the sync account. And by using those passwords, we were able to log in the Microsoft Azure AD portal. OK, so we tried to update the password of a global admin within the cloud, within the Azure AD, but because of some recent updates of the Microsoft, or you can say the security stuff, sync user now only can update passwords of the users who are being synchronized on-prem. It cannot update the password who are not being synchronized. So because of that, we got some limitations, but we did found one user who was on-prem synchronized, but because our client didn't give the permissions to update those passwords, so we didn't do that. But ultimately, we had global admin permissions if we would have updated the password of that global admin. So this is the attack part that we did, where you can see we've reached to the sync user by compromising the function app, then going to machine 1, then machine 2, which is the AD Connect server. And then from SQL, we compromised the sync user, and indeed, we were a global admin. So, okay. So now we have another attack part, which is reader to Intune admin. So here, we'll go back to the attack path, where you can see we have a logic app, then we have a workflow, and it goes up. We have app.readWrite. So now what we have done is we have gone to the left side. Now we'll go to the right side, assuming that we have not yet gained any global admin permissions, or owner permissions. OK. So since we have an app compromise which has permissions of application read, write, all, so we perform more enumerations and found out that there is an app who had a contributor role over a resource group, and that resource group this time has the automation accounts. So, and that automation accounts were using some credentials. Although, even after being an owner or contributor, you cannot read those credentials because it's kind of like a password. It's like if you create an IAM key or client secret, you can't read it back. So because of which, yeah, so these were some credentials so which we were not able to read. So we can't read the value from the portal nor from the APIs, but the runbook can, and we had a contributor role. So we took the permission from the clients, and we created a new runbook in PowerShell, and that PowerShell was responsible to print all the credentials within the automation account. Yeah, it's the sample code. And this is the PowerShell CLI commands which we use. So first we created a new runbook, the first command, and the second command executes that runbook. And once that has been executed, we can read the output from the automation account jobs. And one of the credentials gave us the clear text credentials of Azure user, and that user was the Intune admin. Although when we logged in, it asked us to configure an MFA. Like the user didn't even configure his own MFA, so it asked us to configure the MFA. But because of some conditional access policies or some other stuff, we were not able to perform that, because when we reviewed some conditional access policy, it was written that only from the hybrid joint devices or the compliant devices, from within those devices, you can configure your MFA. So we tried to fake a compliant device, but the problem was there was some another policy which is called Intune policy, and because that was getting failed, so we were not able to configure the MFA of that specific user. This is the way we use AD internal tools to compliant our own WKL VM, and it got added in the client's devices. But since Intune policy was messing up, we were not able to configure the MFA. Okay, so we were able to make the device compliant using AD internals, but we were not able to enroll the device in Azure in Intune due to Intune policy. We were still able to enumerate scripts. Being a reader role, having a global reader, you can still enumerate all the scripts. So scripts are something in Intune that, as an admin, you can execute those scripts within the devices like Windows, Macs, and Linux. So like every 1 hour, you can just make sure that your employee's device gets that script executed. So scripts of Mac OS are getting exposed in the Intunes, so that allowed us to get some more credentials. So this is the red circle which you can see we are till here right now. And yeah, we found the credentials of local administrator, and we found the license key of CrowdStrike in the Intune. So we could have used that for ourselves, but since it's a client, so we can't do that. Okay, next we have a reader to DevOps contributor attack path. So DevOps works completely different from the intra ID. Like it doesn't comes within the intra ID like AD or the subscriptions. It works completely different, and you don't even need to have any subscriptions to have your own DevOps. Any user can create his own DevOps organization or projects. So DevOps doesn't need any subscription like intra ID, and since we didn't find any leaked PAT. So while performing all those testing, we didn't found any secrets, any app or any other key which had permissions to access the DevOps. So we had to ask our clients that please give us a basic reader role so we can do further testing. And hunting starts. So our first motive was to gain as much as privileges within the DevOps which we can. So we quickly took a glance over DevOps project permissions. And we found a group which had a contributor role. And we currently did have an app which has a group read write all permissions, as I talked in the previous one. So by having those permissions, we added ourselves in that group, which is the AAD group. There you can see we can confirm that that group is the AAD group. We added our own tested user within that group, and we were able to create some files within the client's DevOps. Not just create, we could have delete the files, we could have update the files, we could have backdoored their whole source code, and we could have done a lot of stuff, but since it's a client, so we can't do that much things. Uh, yeah, so we had contributor role over DevOps. Additional stuff with reader roles. There was a huge list of repos in the projects. Like I remember there were like more than 800 repos. So we just took a glance by doing manually going through all the source code, and within like just half an hour we found tons and tons of credentials like DevOps, personal access tokens, database connection strings, service principal credentials, intra-ID username and password, API keys, and a lot more stuff to say. But yeah, we did found a lot of things, and we could have done more damage to the client, but since it's a client, we can't do that. And yeah, now we are here, which is lots of hard-coded data, and we could have just throw a bomb and you cannot do anything. Okay, so this was all the succeeded thing which I have talked about. Now let's talk about one failed attempt which we were not able to do it. So since we had owner permissions over the subscriptions, we planned to compromise global admin by abusing storage account. So you all have heard about the Cloud Shell, right? So in Azure, what happens is when you create a Cloud Shell, there's a storage account also being created. And in storage account, we have a disk file, which is like .img file within the storage account file share. Now, because we were the owner, we can access all the storage accounts. So to identify those storage accounts, it's very simple. Those accounts starts with name CS, and the file share name starts with CS dash and the username of the user. So any user with storage account contributor permissions can enumerate these storage accounts, and within the file share, we can find a file which is .img, which you can see in the image. This file used by Cloud Shell for a disk file, and it's like it gets mount to the Cloud Shell. And because it's a ext2 file system, so we need a Linux version, Linux OS to mount this in our local system. And if we take a quick glance within the Cloud Shell, we'll see there's a .azure folder automatically being created whenever someone opens a Cloud Shell. And within this folder, there are all the access keys, tokens. Okay. Looks like he got afraid of me. Maybe if I would hack him. Okay, I'll just verbally talk something about that. So whenever a Cloud Shell is being used, so there's a folder named as .azure. So .azure folder is basically a folder when we use AZ CLIs, and within that we have all the tokens, all the refresh tokens, access tokens. So that is being used for AZ CLIs. And but if we download that .img file within the which was there within the file share, and if we download that within the local system, we won't have those credentials. So, but we could backdoor those credentials. Like let's say if I download that file .img, mount it in my own local system, and do some backdooring like this. So there are two files which is known as .bashrc, and another one is Microsoft.PowerShell_profile.ps1. So if a user opens bash Cloud Shell, that any code written in bashrc will get executed. If it opens a PowerShell terminal, then any code written in that PowerShell file which will get executed. So that's what we did. We downloaded the disk, mounted in our own local system, updated the code, and here is the code. So this code says zip -r azure folder.zip and zip hold .azure folder, and send it over to the attacker. Okay. Okay, so basically we are just stealing the folder, making it a zip file and uploading to my own server, and through which if any user opens the Cloud Shell, in my system I will get that zip file. We did it for both Bash and PowerShell, but it got failed because the user never opened the Cloud Shell when we started doing pen test. So this was a failed attempt. And this is how it looks like. You have an attacker compromise the file share, downloads the Cloud Shell IMG files within the local systems, update the IMG file, send it back to the storage account, and it is like 5 GB of file. We upload back to the file share, and whenever the admin opens the Cloud Shell within the Azure portal, automatically the malicious code gets executed, and we would get the complete Azure tokens and everything within our own account. I mean, within the own server. So this way we could have leveraged it, but I don't know why that guy didn't open the Azure portal or something. Or maybe he would have got some clue that we are doing something. OK, these are some of the reference links. So the first two links are the part of the attack which we did, and the third one is on the function apps which you can explore. And yeah, this is all the attack things that we did. If you want to connect with me and want to know more about the attacks, because I can't teach all the attack parts in just 1 hour, because I would need like 3 hours of time. So if you need to connect to me, please feel free to connect with me via LinkedIn or Twitter or anything. Yeah, thank you.